For problem number 4, we've got another inequality, but this time we have absolute value bars. And so similar to when we're solving an equation, we want to go ahead and get the absolute value bars by themselves on the left side of the equation, or in this case, an inequality. And we do that first by subtracting 3 from both sides. And subtracting 3 from both sides gives us negative 14. Negative 11 minus 3 is negative 14. Then we're going to divide both sides by negative 2. And dividing both sides by negative 2, we end up getting the absolute value of something by itself. Now, again, we've divided by a negative, so we're going to flip the direction of the inequality symbol. Less than or equal to 7. That means that 4x minus 1 has to be within 7 units from 0 on the number line. So we're going to sandwich, this is an AND statement, we're going to sandwich 4x minus 1 in between 7 and negative 7. Now, we want to solve for x by getting x by itself by adding 1 to all 3 parts. If we add 1 to negative 7, we get negative 6, less than or equal to 4x, less than or equal to 8. And then if we want to get x by itself, again, we divide both sides by 4, but then there's 3 parts, so we're going to divide all 3 parts by 4. And we end up getting negative 6/4, which is 3 halves, less than or equal to x, which is less than or equal to 2. So negative 3 halves in between, or x is in between negative 3 halves and 2. So if we want to write that on the number line, we put 0 there, negative 3 halves, we know it's negative, so negative 1.5. And then over here we'll put 2. So x is in between negative 3 halves and 2. Now, that right there is the graph notation. Here we have the inequality notation. Then we have the graph, the representation of that solution set with a graph. And then we also have the interval notation. That would be the interval from negative 3 halves all the way to 2. And then my question here, number 5, it says in your own words, describe the answer to number 4. Well, the answer to number 4 is all real numbers between and including, I'm wondering if you can finish my sentence. And I would really like you to pause the video and see if you can finish that sentence. All real numbers between and including negative 3 halves and 2 make the original statement true. Certainly there are other ways you can say that. You could have said something like, the solution to this inequality is all real numbers between negative 3 halves and 2, including negative 3 halves and 2. So the bottom line is, I want you to understand that what this represents is the solution set to the original inequality. If you shade the numbers, it means the numbers make the original inequality true. Same with the one up here, same with number 3. So there you go, there you have it. Hope you're ready for the test.